Good morning, everyone. This is the last lecture of the chemical calculation and equation chapter. First of all, let's just go through example 11 and see what it requires from us. Now, calculate the number of moles. So we need to find out the number of moles of copper atoms formed from the reaction of 4,250 ml of H2 with enough CuO copper oxide under standard condition. So when we say standard condition, it means that the temperature is 25 Celsius and the pressure is 1 atmosphere. So first of all, let's just determine which is known and which is unknown, and then we will be able to figure out the law that we must apply in order to get the number of moles that is required. Now, the known here is the volume of hydrogen, okay? And the unknown is the number of moles of copper. So first of all, we need to convert the volume of hydrogen from the milliliter into liter, because we are dealing with liter. So like the magnitude of our stuff or molecules are like a liter. So now, so we can like use this mathematical expression to do that. V per liter to 4,250 ml of hydrogen times 1 liter of 1,000. So we divide by 1,000 in order to get it or to convert it into liter. So we got 4.250 liter of hydrogen. Second of all, so we have this law, okay? So we can use it to find out the number of moles of what? Of the hydrogen. And from the number of moles of hydrogen, we can find out the number of moles of copper. Because we don't have anything like about copper. It does not like give us any, numbers or any like volume or any mass of copper. So we only have the volume of hydrogen. So first of all, we find out the number of moles of hydrogen using the volume of hydrogens, and then from the number of moles of hydrogen we can find out the number of moles of copper. So this is the number of mole of hydrogen, which is 0.19. So using this mathematical law or expression, and then we can like use this expression as we mentioned previously. Like we had more than one example talking about the same process. So the number of moles of the known, which is the hydrogen that we just calculated, okay, times the number of mole of the unknown from the equation right here. So how many copper? We have only one mole, right? There is no number like before it, so it's one mole, okay, which is right here, over the number of moles of hydrogen from the equation as well, which is 1. So 1 over 1 equals 0.19. This is the number of moles of copper, right? It's simple. Now let's move to another example. Example 12. 0.4 mole of potassium chlorate decomposed with heat according to the following equation. So we have this equation, and now we need to calculate the volume of O2. So you just write everything down, the known and the unknown, and then you will be able to figure out which is required and which is given. All right. So let's just begin and see which is known. So we have only the number of moles of KClO3, the potassium chlorate, which is right here. It is given, right? And we need to calculate the volume of O2. So it's simple. So as long as we have the number of moles of one of the components, so we need to use it in order to find out the number of moles of the other component. Okay, so we will be using the number of moles of KClO3 right here, okay, to find out the number of moles of oxygen. And from the number of moles of oxygen, we can find out the volume of oxygen. Now, first of all, we are dealing with what? we're dealing with not oxygen, sorry, not Celsius. We're dealing with what? With Kelvin for here, the temperature. Okay, so we need to calculate or to convert the Celsius right here for the oxygen into Kelvin. So we say T per Kelvin. This is the law that you need to memorize. T Kelvin. If you wanna like convert the Kelvin to Celsius and vice versa, the Celsius 27 plus 273. This is constant. If you want to do the reverse, you just like say 273 minus 27. If it's given like Kelvin and you need to convert it into Celsius. So we got all the thing ready. So now we like need to convert or to find out the number of moles of oxygen using the number of moles of KClO3 right here. So the number of moles of KClO3 times the number of moles of the unknown, which is oxygen, from the equation. So how many we have? 3 right there. Okay, let me just highlight it. Okay, it's 3. Okay, over the number of moles of KClO3, which is 2 right here in the equation. Okay, and then we get the number of moles of oxygen. Now let's just use the law that we just explained previously. V equals nRT over P. This is the pressure, right? Now V per liter equals the number of moles we got it, and we just calculated 0.6 mole, which is right here. Okay, times this is constant 0.082 liter by atmosphere over Kelvin per mole. So now this is the reason why we converted the temperature from the Celsius into Kelvin, because if it's in Celsius, then I will not be able to cancel them out, the units. Okay, so now I wanted or I needed to convert the Celsius into Kelvin so I can like neglect them out or cancel them out, this one and that one. Okay, times 300, which is in Kelvin, over 1 atmosphere, because it's in what? Because it's STP. Okay, or sometimes it gives you like in tour. So 762, this is a unit of pressure. Okay, equals 1 atmosphere. So you don't need to convert it. But if it was not 760, if it was like number like 1000 or something like that, you need to like do a mathematical expression, or using a mathematical conversion in order to get it in atmosphere, because the pressure here is an atmosphere and the temperature is in Kelvin, not in Celsius. And we got the volume of oxygen. All right.